Yeah. Hi, welcome to lesson 15 of our geography series. In this class, we are going to learn about ocean currents. In previous class, we have learned about planetary winds and seasonal winds. How planetary winds are generated. The winds that blow on entire planet are called as planetary winds. How they are generated, we learned about it. How do they generate due to the development of different pressure belts at different latitudes? Okay, these planetary winds have their effect on an entire Earth. Okay, and moreover, these planetary winds are also influenced by Coriolis force, right? And also pressure gradient also. Similarly, due to action of these planetary winds, uh, ocean movements in the ocean are also generated. Okay, and these generated movements are called as ocean currents. So, in a way, ocean currents are nothing but they are similar to a river flow. How does a river flow? Similar to it, oceans also do flow. Okay, but in a very large volume, that is from one area to another, from southern hemisphere to northern hemisphere, or from higher latitudes to lower latitudes. Oceans move as a current. That is, flow as a current means nothing but move as a flow. It is called as a current. So they move as a current from one latitude to another latitude, and these currents are initiated by four types of forces. Okay, first one is solar energy. Second one is winds. Third one is gravity, and fourth one is Coriolis force. Okay, these are responsible for of movement initiation of movement of ocean water. Yes. How do solar energy influence initiate it? Due to more heating at the equatorial region, what happens? The oceanic water expands in size due to more heat. Hotter bodies do get expands. Okay, whether it is any body, whether it is a liquid or a solid, due to intense heat, what happens? Any body expands in volume. So oceans get expanded in equatorial region and lower latitude region. Lower latitude means 10 degrees to 15 degrees. Okay, and then what happens due to large volume at lower latitudes, and due to less heat at polar region or higher latitudes, what happens? Water will move from higher volume areas to lower volume areas because a gradient is developed. It is equatorial region, water is expanded. Okay, and so it will be in a upper position, and at polar region water will not expand and will be in a subsiding down position. So a gradient is developed, like a upstream gradient is developed, and water moves from expanded region to lower region. So in this way, solar energy initiates the movement. And second one is our winds, that is planetary winds. Okay, for example, in equatorial region, planetary winds initiate the movement from west to east. In subtropical region or lower latitudes, in northern hemisphere, waters move in northeast direction due to northeast trade winds. Okay, and at polar region, due to easterlies, waters move from east to west direction. That means oceanic water, due to presence of winds, and also due to friction between these winds and oceanic water, the direction of oceanic currents is also influenced by these winds due to friction between them. As these winds strike the moving oceanic water, they make these ocean water to move in different directions. Okay, that is about winds. And gravity. Gravitational pull is more at polar regions as they are nearer to center of the earth, and at equator gravitational attraction is less because equator is farther from the center of the earth. because equators are bulged. And due to this difference in gravitational force, the more gravitational pull at polar region will attract the water from less gravitational region, that is from equatorial region and lower latitude region. That is about gravity. And Coriolis force. What does Coriolis force do? It makes the once the movement is initiated, it makes the oceanic water to move in clockwise direction or right direction in northern hemisphere and left in southern hemisphere. Okay, this is about initiation of movement and influencing of the movement. Once the movement is initiated, movement, that is the oceanic water starts moving, and after the initiation of the movement is influenced by planetary winds and Coriolis force. Okay, that means once the influence means these planetary winds and Coriolis force, what do they do? They influence the direction, velocity of the ocean currents. Once the movement of the oceanic water started, due to planetary winds, the direction of the ocean currents might change, and also velocity might change. More is the wind, more will be the velocity. And also due to Coriolis force also, oceanic waters get deflected, and at polar region the deflection will be more due to more Coriolis force, and at equatorial or lower latitude region deflection will be less due to less Coriolis effect. So initiation is due to solar energy, gravity, Coriolis force and winds. And also influencing of the oceanic movement, influence in the with respect to their direction and velocity, is by planetary winds and Coriolis effect. Okay, and next, after this, after this is about horizontal movement. Due to these forces, what happens? Oceanic water moves in a horizontal way, right? Next, vertical movement of the oceanic water. Vertical movement means if this is oceanic water sinking down and moving. Okay, how this vertical movement happens? We know that cold water is denser and warm water is light. So what happens? The denser water, sorry, yeah, the denser water at polar region sinks down. Okay, the denser water at polar regions, which is very cold in nature, it sinks down and move towards lower latitude region and rises up and results in the formation of cold currents. And warm currents or warm water at equatorial region will expand and move towards polar region and results in the development of warm currents at the polar region, so that the temperatures at these regions are balanced, right? Due to for example, there is oceanic current called as Canary current, which moves from western coast of Europe, that is from French Spain, and to western coast of Africa. It is colder in nature. The cold waters of North Sea at Norway, Finland sinks down, and they rise up at this French and Spain coast and move along the western coast of northwestern coast of Africa, that is at Morocco. So that what happens? This cold ocean currents influences or not influences, improve the warm conditions of North African region, so that they will be colder due to this cold ocean current. And moreover, at higher latitudes region, the warm water at equatorial region will expand and travel towards the uh, colder or higher latitudes region, and it will influences the temperature at higher latitudes region. This is about the vertical movement of the water. Vertical movement of the water happens due to difference in the densities, so that the cold water sinks down and travels towards lower latitude region, and expansion of the warm water will travel towards higher latitudes region. Yes, this is about ocean currents. And due to these movements, different types of ocean currents are generated on the entire planet of the Earth. And we will look into it now. Yeah. Hmm. See, if you, I think the diagram is clearly visible to you. First, we will wait. First we will look at ocean currents of Atlantic Ocean. Okay, if you look above, this is equator. Okay, this is equator. If you uh, and this is Atlantic Ocean. This region, Atlantic Ocean. Okay, see, above the equator, above the equator, we have north. There is generation of north equatorial current. Okay, I will mention or I will draw warm ocean currents with red ink and cold ocean currents with blue ink, so that you draw accordingly with me. See, at western coast of, near the western coast of, northwestern coast of Africa, uh, north equatorial current is generated. Why north equatorial current is generated? Here the temperature will be more. Okay, in this region the temperature will be more due to this water expands and move towards the Mexico. Okay, so the water it is called as north equatorial current. This north equatorial current starts moving towards uh, Mexico or Brazil, and at Brazil, what happens? See, another thing is these ocean currents are also, the direction is also influenced by the coastline. Coastline means, if you see here, the one, if a current hits a region, it diverges according to the coast of the country. Okay, so north equatorial current travel towards the north of the Brazil. It hits Brazil, and one stream will go into these are called as Antilles region, this Caribbean islands region, and another branch will go like this. Okay, and it covers the Antilles region, and the one that is moving towards north, it travels as the Gulf Stream. Why it is traveling from west to east direction? As these currents are moving upwards, they come under the influence of westerlies. Okay, westerlies of subpolar region, that is, this is above 40 degrees north latitude. They come under the influence of westerlies, and they travel towards from west to east direction. Once they travel towards west to east direction, what happens? They hit the mid-Atlantic ridges. Once they hit the mid-Atlantic ridges, one branch move towards North Atlantic Ocean, that is towards Europe and Norway, and one branch move towards French and Spain. Right. The branch that is moving towards UK and Norway is called as North Atlantic Drift, and it is warm in nature. Okay, because the warm waters of north equatorial current are traveling. Warm in the sense it is comparatively warm. See, compared to surrounding sea at Iceland and Greenland here, it is warmer in nature. So we will depict the North Atlantic Drift as warm ocean current. Another branch moving towards south, that is along the French and Spain, it is cold ocean current, and it is called as Canary current. Why it is cold in nature? Because the Norwegian Sea, that is, this is North Sea. Norwegian Sea is very cold in nature. It sinks down and rises at French and Spain coast, or northwestern coast of Africa, and Canary current is generated. It is cold current. Okay, and coming to South Atlantic Ocean. due to influence of southeast trade winds. See, due to influence of southeast trade winds, sorry, south equatorial current is generated, which moves from west coast of Africa towards the east coast of South America. This is south equatorial current. It is warm in nature due to influence of southeast trade winds. Okay, and it moves towards the Brazil, hits Brazil coast and moves downwards. One branch moves northward and joins north equatorial current, and one branch moved towards south as Brazilian current. South equatorial current moves from west coast of Africa towards east coast of South America because of southeast trade winds. And once it hits east coast of South America, that is Brazilian coast, two branches are generated. One branch moves northward and joins north equatorial current. One branch moves southward and southward as Brazilian current. Both are warmer in nature. Okay, and from here there will be Antarctic region, right? From Antarctica, cold ocean currents travel towards Argentina. This is Argentina. Cold ocean current. This cold ocean current is called as Falkland current. Okay, this cold ocean current is called as Falkland current. It travels towards Argentina, and due to influence of westerlies, it starts traveling west to east as west wind drift. Falkland current, after entering from Antarctica to this Falkland region, it is called as Falkland Islands. It is cold ocean current. Once it reaches Argentina, what happens? It comes under the influence of subpolar westerlies, and it moves towards west, from west to east as west wind drift. And this west wind drift is also uh, what, colder in nature. This west wind drift starts moving towards tip of South Africa and breaks into Beniguela current. This Beniguela current is also cool in nature, and this Beniguela current, what it does, it joins the South Equatorial current. Okay, these are the currents in what, Atlantic Ocean. Okay, I think it's much clearer to you. North equatorial current is generated on the northwestern coast of Africa. Why? Due to more temperatures there, the water started expanding and started moving towards Gulf of Mexico. This is Mexican Gulf, this region. And once they reach Gulf of Mexico, they hit the uh, Antilles region. Antilles means there's a group of islands in Caribbean Sea. Once they hit the Antilles, North equatorial current got drifted into two types of branches. One branch moved into Gulf of Mexico, and another branch started moving towards eastern coast of North America as Gulf Stream. Okay, this Gulf Stream, once they hit what, not hit, once they come under the influence of subpolar westerlies, it started moving towards, wait, it started moving towards west to east. While moving towards west to east, these Gulf Stream hit the mid-Atlantic ridges and started dividing into two branches. One branch moved as warm North Atlantic drift towards the North Sea region, that is towards UK and Norway. One branch moved towards French and Spain and along the northwestern coast of Africa as Canary current, cold Canary current. Why cold Canary current? Due to upwelling of cold water from North Sea. And another one is Labrador current. Labrador current originates at 80 degrees, 70 to 80 degrees north latitude, that is northern part of Canada. It is cold current. Labrador current is cold current, and it starts moving towards, you know, towards the Gulf Stream, and it joins Gulf Stream at a place called as Newfoundland. Newfoundland. At Newfoundland, cold Labrador current merges with the warm Gulf Stream current. Okay, and from Antarctica, cold water start accumulating at Argentina, and they travel as Falkland current. This Falkland current comes under the influence of subpolar westerlies and starts drifting towards uh, southern tip of Africa. Start drifting as west wind, start moving as cold west wind drift. Okay, and once it hit the Africa, it divides into Benugula current, and this Benugula current joins with the south equatorial current. Next, if you see clearly, there is clockwise movement of oceanic currents in northern hemisphere and anti-clockwise movement of currents in southern hemisphere because of Coriolis force. And because of different planetary events, some ocean currents started moving west to east, some started moving from southeast. Okay, so this is the influence of planetary events and Coriolis force. And due to upwelling of the water, due to high solar energy, oceanic water started moving as north equatorial current. Okay, this is about oceanic currents in Atlantic Ocean. Now we will see oceanic currents in Pacific Ocean. Yes. So north equatorial current. Once this north equatorial current, what it does, once it enters the wait. Once it entered the Gulf of Mexico, it started moving towards the east to west, north equatorial current. See, north equatorial current is traveling like this. This travels like this and it emerges at Philippines. North equatorial current emerges at Philippines. It starts moving from western coast of Mexico and starts moving towards Philippines. Once it hits the Philippines and starts moving northward. Okay, as warm Kuroshio current. It is warm. North equatorial current travels from western coast of Mexico. See, it travels from western coast of Mexico and emerges at Philippines. It hits the Philippines Islands and starts drifting towards north as warm Kuroshio current. Okay, and next, and something happened. Please give me a second, guys. Yeah. Where were we? North equatorial current hitting Philippines Islands and started drifting northward as warm Kuroshio current. This warm Kuroshio current starts moving towards Japanese coast, and once it reaches Japanese coast, it is met by cold current called as Oyashio current. Cold Oyashio current. Okay, this Kuroshio current meets with Oyashio current, and these two starts drifting towards Oyashio is cold current because it is originating at and there is islands at 60 degrees north latitude between Russia and Alaska. It starts with Bering Strait. It is present between Russia and Alaska. So Oyashio current is generated from Bering Strait. It meets with warm Kuroshio current and they started drifting towards North America. Okay, once they travel from towards North America, they emerge as North Pacific Drift. Okay, it is the Oyashio and Kuroshio current together emerged as north, travel towards east and emerged as North Pacific Drift, warm North Pacific Drift. Okay, once the North Pacific Drift started moving towards uh, western coast of North America, it hits the western coast of North America and started drifting as Alaska current and California current. California current is cold in nature. Alaska current is warmer in nature. Why? Due to upwelling of water. Upwelling of cold waters of Alaska rises at California's cold current, and Alaskan current will be warmer current compared to California current. So, North Pacific Drift divides into Alaska current and California current. And this north equatorial current, after hitting Philippines, we said that the north branch moved towards Japan as Kuroshio current, and the southern branch moves towards, Australia. Okay, moves towards Australia and travels like this. Okay, this is north equatorial current, and these are currents of Pacific Ocean. And moreover, due to influence of subpolar westerlies, west wind drift, it is cold in nature. West wind drift originates in Pacific Ocean and starts moving from west to east. Okay, this west wind drift is also Falkland current merges with the west wind drift and starts moving towards Africa, South Africa, and diverges into Beningula current. And west wind drift starts moving from west to east. Okay, once it reaches, it travels from west to east. What happens? See, it moves towards Australia as West Australian current. It is colder in nature. This west wind drift, due to influence of Coriolis force, once it reaches uh, Australia, near Australia, it travels towards Australia due to influence of southeastern trade winds. See, it comes coming from west to east, and due to influence of southeast trade winds, it is traveling from southeast as West Australian cold current. And this West Australian current is merged with South Equatorial current. So this South Equatorial current here is warm. West Australian current is cold. Okay, this South Equatorial current starts moving towards east coast of Africa, hits Madagascar, and travels as Agulhas current. Okay, Agulhas current is warm in nature. South Equatorial current hits Madagascar coast and starts traveling as Agulhas current along the eastern coast of Africa. Okay, this is about uh, ocean currents. Make sure you draw it and listen to the class once again, and make sure you draw ocean currents from the starting point where I started from north equatorial current, and also write which are cold and which are warm, and also write the reasons behind it. I have also explained to you reasons why they are cold, why they are warm, and why they are moving in particular directions. I have explained the entire reasons behind them. And moreover, I have said that this north equatorial current will hit the Philippines and move as Kuroshio, and south one moves along the eastern coast of Africa, and it enters New Zealand. This New Zealand is entirely surrounded by the warm north equatorial current. And so this is about oceanic currents. And there is another thing called equatorial counter current. This equatorial counter, see here, equatorial counter current. This equatorial counter current is nothing but uh, during equinox time, as the equatorial westerlies are stronger, ocean along the equator starts traveling from west to east along the circumference of the earth. It is called as equatorial counter current because it moves opposite to north equatorial current direction. Look here, south equatorial is they're both in same directions, and equatorial counter current is opposite to this, so it is called as equatorial counter current, right? And moreover, now we will look into oceanic currents in Indian Ocean. In Indian Ocean, what happens? These oceanic currents are influenced by monsoon winds, that is seasonal winds. So in previous class, we have learned that during summer solstice, there will be southwest trade winds, and oceans also move along the southwest region like this, from Arabian Sea to Bay of Bengal. Okay. Ocean also moves along the southwest trade winds. But during winter solstice, we cannot see oceans in South Indian Ocean moving along the seasonal wind, that is northwest trade wind. Okay, because in North Indian Ocean there is predominance of land, so that the movement is influenced due to differential rate of heating of ocean and land. But in Southern Indian Ocean there is more ocean, and the influence is very much less. And this south equatorial current movement is generally present during winter solstice also. Yeah, this is about wait, oceanic currents. Make sure you note each and every one of the reason behind the oceanic currents and effects of these oceanic currents. Uh, I will explain it to you when we are in the world climate. During while we are studying world climate, we will take up each and every continent and each and every region and study the climatic conditions over that region. While studying the climatic conditions, once again we will come across these oceanic currents and this ocean how these oceanic currents are influencing climate of that particular region. We will look into it once we enter what world climate. Okay, and we will also talk about El Nino and La Nina during world climate also, because this El Nino and La Nina are closely associated with the movement of the ocean currents along in the Pacific Ocean. Okay, we will look into it once we deal with it in Indian climate, because during El Nino we have droughts and La Nina we have floods. So I will explain about El Nino and La Nina while we are discussing about Indian climate. For now, this is about oceanic currents. Yesterday, our previous class, we have learned about planetary winds. So, and today we have learned about ocean currents. These currents influence the entire climate of the Earth. In next class, we will talk about air masses, fronts, different types of clouds and rainfall, cyclones and anticyclones. Okay, with that we will complete climatology and enter into world climate. Okay, yeah. Thank you. If you have any doubts, please do let me know in the comments. And again, I am saying, please do visit climatology classes time and again so that you won't forget the logics. Today, the class is very it's very less time because you have to learn about these ocean currents and even previous class is also very less time. You have to learn them individually and make sure you have a complete idea on that, how winds are blowing, how ocean water is moving. Okay, and understand the logic behind them. Okay, yeah. Thank you. Yeah, and please do let me know if you have any queries or any doubts in the comments. Yeah, and in next class we will start with air masses, fronts and frontogenesis. I will explain what are those terms. Yeah, thank you.